you know? So r hat should point like this, and theta hat should point, yep, like this. That would be a unit vector, right? It better be. So if that is there, right? And if the, you know, if this is the unit circle down here, then, I mean, my picture's not quite right? So if it's a unit vector, it should only be as big as the unit circle, right? So it should be like, this. And because you guys know how the unit circle works, you can see that the point right here should give us cosine theta, sine theta. But because we're in 3 dimensions, 0. Right? When we translate that to the u1, u2, u3 notation, we get cosine theta u1 plus sine theta u2. And the theta hat, on the other hand, minus sine theta, cosine theta, because it goes that way. Take the dot product of r hat and theta hat, what do you get? You get 0, right? Because you get minus cosine sine plus cosine sine. And u3, well, that's just vertically, right? Z hat is easier to calculate. The gradient of z divided by the length of the gradient of z. What's the gradient of z in 3 dimensions? 0, 0, 1, right? Think about gradient of f was, what was it in 3 dimensions? fx, fy, fz, right? So if I take the gradient of the z function, I get 0, 0, 1. Divide by the length of it, what do I get? It's kind of silly, but I'm just pointing out that you can think of z hat as being the gradient of the z function divided by the length of the gradient of z. I'm just telling you this. It's a way you can derive the coordinate frame using calculus if you want. But there you go. This is, in fact, an orthonormal frame. You can check that, in fact, that r hat cross theta hat is, in fact, z hat. That is, in fact, the case. And that's why cylindrical coordinates are a right-handed coordinate system, because the frame which they define is a right-handed frame. And I would say it's on all of R3, but, you know, the origin is problematic. Okay? But if you're willing to overlook a point, it's a frame on R3. 3, guess what? Rho hat, theta hat, phi hat. Also a frame. Now here we got to be careful. The spherical, right? If we define as follows. Now you got to be careful because the spherical coordinates that are in the spherical, oh, good grief, it was supposed to be cosine theta sine phi. I'll get it eventually. Cosine theta sine phi, y equals to rho sine theta sine phi, z equal to rho cosine phi. That choice of formulas, the way geometrically those work, if you give me a point down here, phi, as I have defined it, sweeps off the positive z-axis like so. This is the usual math convention, right? So phi equals to 0 is the z-axis. Phi equal to pi is the minus z-axis, if you will. And theta is the standard angle. Theta is the same as it was in the cylindrical coordinates. So to get theta, it's a little bit complicated. You have to drop the image of this down to the xy plane, and then on the basis of that projection, here, you sweep theta down in the xy plane, right? So we have 0 less than or equal to theta less than or equal to 2 pi, and traditionally 0 less than or equal to phi less than or equal to pi. In practice, we bend the rules and we integrate stuff from minus pi over 2 to pi over 2 for theta all the time, right? Like, we're not dogmatically attached to 0 to 2 pi for theta when push comes to shove in our integration in Calc 3, if you think about it. But at least this is a choice we can make. So I'm warning you about this because in O'Neill, he has a different definition of spherical coordinates. His spherical coordinates have an angle which sweeps up off the, his 0 phi is like the equator, and it sweeps up. So the positive hemisphere has positive phi, and the negative hemisphere has negative phi. It's actually kind of cool, and maybe it's even a better choice of angle. I think maybe, I mean, I might be persuaded to use it all the time if it wasn't for the fact that these are kind of like the dogmatic standard in Calculus 3, right? Yeah. When I teach Calculus 3, guys, I don't use, so you guys have been taught to use these things, right? It's kind of the industry standard. I don't use those. I will teach with this, x hat, y hat, and z hat. And the reason I do that is because what that is the unit vector in the direction of increasing x. This is the unit vector in the direction of increasing z. This is the unit y. This is the unit vector in the direction of increasing z. It means the same thing. Unit vector in the direction of increasing r. Unit vector in the direction of increasing theta. You know? And down here, guess what the spherical coordinate frame is? It's rho hat. Oh, I think I put them in the wrong order. I think I need rho hat, phi hat, theta hat. The order matters. So E1 is rho hat, E2 is phi hat, E3 is theta hat. Let's see if I got the order right. If I got the order right, E1 cross E2 should be E3. So we need to pick a point, visualize the vectors, and see if I got it right. Let's pick this point right here. What direction does phi hat point? It points in the direction of increasing phi. So phi hat at that point right there looks something like this. What direction does theta hat look like? Well, it's pointing into the board like that. So theta hat looks something like that. So let's see here. And then, well, rho hat is just in the direction of increasing rho. It's kind of like it points spherically out from the origin, away from the origin, directly away from the origin. And here's where the limits of my artistry start to really impinge on the understanding. But it's hard to see the difference between like that. So if you can imagine rho hat, see here, rho hat crossed into phi hat points into the board. I think I got it right. Rho hat, rho, phi, theta has to be the order of the coordinates if we want it to be a right-handed coordinate system. I have a grammatical preference for saying rho, theta, phi, but I shouldn't do that because if I do that, it makes it a left-handed coordinate system. We have to do rho, phi, theta as they're currently defined. Now you might wonder what's the formulas. All right, let me tell you what the formulas are. E1, now this one's kind of easy because you can think about the unit sphere, and if you can imagine the unit sphere at the origin, rho hat should just be the point on the unit sphere translated out, in the same way that r hat was the point on the unit circle translated out. So the formula for rho hat you can geometrically understand by just putting rho equal to 1 in these formulas. E1 is nothing more than cosine theta sine phi U1 plus sine theta sine phi U2 plus cosine phi U3. All right? Now, the other two, well, E2 is theta hat, right? We already know that one. It's not different. That's the cool thing about that's the good thing about the usual coordinate choices in Calc 3 is that theta for cylindrical coordinates and theta for spherical coordinates are the same theta, right? So it's still the same theta hat, actually. And E3 is, E3 is complicated. I got to look it up. I don't remember E3 right offhand here. It is, blah, 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 blah. Where'd you go? What? Oh, I'm an idiot. I'm like, that doesn't look right at all. What if I completely just ignored the ordering? I just got done giving this song and dance about order matters, right? How about I pay attention to it? E2 is phi hat. E3 is theta hat. This is not E2, this is E3. E2 is the horrible one. So I think I don't know. So in my printed out notes, I have a sign error. I don't know if I corrected the sign error in the copy you guys have or not, because I printed these a few years ago. But I believe what should go here is cosine theta, cosine phi, u1, minus sine theta, cosine phi, u2, plus sine phi, u3. We can check me on this what should we do is we should pick a particular point that it's very easy to think about phi hat, right? What's an easy point to think about phi hat? How about this? What if we pick the point like right here? That point should have phi hat pointing directly down. So phi hat should be equal to minus u3 right there. Can you guys tell me what the coordinates are for that point? In terms of angle? What angle are we at there? Phi equals what? Theta equals what? If you get one, you get the other. No. Theta is 0 on the x-axis. Theta swings out from the x-axis. It's the positive. 90 degrees, right? Pi over 2. And phi also? Also pi over 2, yep. So what happens if we put pi over 2 into this here formula? Yeah, cosine of pi over 2 is 0, right? So 0, 0. Plus u3, I think not. So, well, this should definitely be a minus sine phi. All right, how can we double check this term? What angle should we use to double check that term? Pi. What? Let's see here. Pi. What do you say? Pi? Which one's pi? Phi. So you say look at phi equals to pi, and theta equals to pi over 2. I want to choose angles. Yeah, I want to choose angles so that I only get this term non-zero.
So you would have to be pi for sure. No, then you get the cosine one. No, yeah, that'd be pi over 2. The thing
if I do,
Sine would be 1, cosine would be cosine phi, not 0.
so that if I did that, this would suggest E2 equal to U2 from this formula, because cosine of cosine of pi is minus 1, and sine of pi over 2 is 1. So I get minus 1, minus 1, just give me 1, right? Now the question is, geometrically, does that make sense? Where would we find theta, phi equal to pi and theta equal to pi over 2? Down here somewhere, right? Oh. Ah. Oh, that's unpleasant. That's right on the edge of things not... I don't know if things make sense on the z-axis, actually. I mean, I guess, that's saying phi is like that. No, phi is like this. I think things break down on the z-axis, actually. Unfortunately, that's exactly the point I can't get to. Okay, anyway, I'm sorry, guys. There's a typo in the notes here that I don't know how to fix right offhand. Actually, I do know how to fix it offhand. If these two are definitely right, and I'm pretty sure these two are exactly right, the way to get E2 is from taking, and this is horrible, E3 cross E1. Oof, indeed. I earned a oof. I have succeeded. So if I took this cross that, I should get the correct E2. Also, another way to check signs is like the dot product of this with this and this with this should be 0 if it's right. So if I start taking dot products here, I get minus sine theta, cosine phi. I get minus sine theta, cosine theta. So I think this has to be a plus in order to get this dot that to be 0. And to get this, that gives me minus cosine sine, and this gives me sine, sine, cosine, sine, cosine, cosine, sine, sine. I think this is right. Just like this, yeah. Because I just took dot products of E1 and E2, and I mean rather E1 and E2, and I think I got 0 because I get a minus cosine sine from the U3 terms, and I end up with like a cosine squared plus sine squared times cosine sine.
Yeah,
so I think this is right. Sorry. Okay, so I think this is a good place to take a little break, and just give me a few minutes here, and I'll eat my dinner, and then we'll start again. And I'll try not to